zeros of polynomial functions. Our objective, use factoring to find zeros of polynomial functions. We're also going to take a look at them on the graph. So what do we know that's going to help us? Well, we know what a polynomial function is. A function of the form f of x equals coefficient times x to a power plus coefficient times x to a power plus et cetera, all the way down to a constant. And it is in standard form if the exponents are decreasing order from left to right. So for example, 5, 4, 3, 2, 1, 0. Okay, we also know what factoring is. Factoring as a verb means we are finding what to multiply to get, in this case, the polynomial. Okay, so we're writing a polynomial as a product. And when we write it as a product, the pieces are called factors. What kind of factoring do we know how to do? Well, we know how to factor using a greatest common factor. We know how to use grouping. We know how to do trinomials. We know difference of squares. And there are other factors you may have worked with in the past, but those are some of the popular ones. We also, factoring along with the zero product property is a method for finding a function's solutions. Okay, so we're going to find solutions which are also called zeros. Let's note that. Solutions to polynomial functions of degree 2 and higher are also called zeros or roots. So all three of these words have similar meaning. We're going to focus here. More often than not, we're going to call them zeros, but they're also called solutions and they're also called roots. So what does it mean to solve a polynomial? It means you want to find its zeros or its roots. Okay, you do that by setting the polynomial equal to 0 and finding the values of x which satisfy the equation. In other words, make the left side equal to 0. Let's take a look at how to do that with some examples, and we'll also take a look at our graph. Example 1 here, find the zeros of the polynomial function x cubed plus 3x squared minus x minus 3. Okay, this problem I know about. This problem can be solved if you factor it by grouping. First things first, we want to find the zero, so we need to set it equal to 0. So x cubed plus 3x squared minus x minus 3. That's how we find the zeros. We set it equal to 0. This one can be factored. If I factor an x squared term out of this, I'm left with x plus 3. And when you factor by grouping, you want to get a similar factor again. Well, if I take out a negative 1, I'm left with the same factor, x plus 3. Negative 1 times x is negative x. Negative 1 times positive 3 is negative 3. So I was able these are already grouped for me. I took an x squared out of these two, and I'm left with an x plus 3. I took a negative 1 out of these two, and I'm left with an x plus 3. This is called factor by grouping. It's available sometimes if you notice it. So now I have a common factor of x plus 3. So I'll factor that out, and I'm left with times x squared minus 1. Okay? So that's how factor by grouping works. If you recall that from perhaps your Algebra 2 days. Now, I just need to, I can now utilize the zero product property. If A times B equals 0, then either A equals 0 or B equals 0. Okay, that's the zero product property. So x plus 3 equals 0 or x squared minus 1 equals 0. Well, this says that x could be negative 3 and I'll get a 0. If I add 1 to both sides, this one tells me that x is equal to positive or negative 1. So I have 3 zeros. And I wanted to find the zeros. I have 3 zeros, and they are, and I'll put them in brackets, why not? I'll put them in also in order from least to greatest, -3, -1, and 1. Let's take a look. Those zeros are x-intercepts, as we know. Okay, so it looks like I'm my graph. I've got to do some changing here. My function, my polynomial was a third degree polynomial, plus 3x squared minus x minus 3. And I'm going to go to my standard window, and here comes my polynomial. And you can see it crosses the x-axis 3 times. Those are my 3 zeros. What are they? Well, I can look for them in 2 ways. I can go to second calc and 0, and I can go to the left and right of each of them. So I'm going to look at the one here on the left, which looks to be -3, and I'll bracket it above and below. And look here, 1 0 is -3. Well, I knew that. That's the 0 right there. Okay, and I can do the same thing. I can calculate the zeros for this one and this one. I bracket them, second calc 0, and I'll see that -1 and +1 are also zeros. Because they're integers, I can also go to my table. So go to my table, and because my table is x integer values, I can see that there's a 0 at -3. Here's a 0 at -1, and here's the 0 at +1 right there. So I can also use my table, and my table is currently set up so that my x values are integers. Okay, I want to note one thing. Let's make a note here. Note, it's a third degree polynomial, and it has 3 zeros. Okay, so a third degree polynomial, this one has 3 zeros. Okay, we want to make a note of that. Let's do another example. Okay, example number 2 here. Find all, let me get my paper turned over, or get the new piece of paper. Find all the zeros of this function, which is x to the 4th minus 4x squared. This is a 4th degree polynomial. And the first thing I do to find the zeros is I set it equal to 0. Whoops. And I use a minus sign there, not an equal sign. Okay. And now I'm going to pull out the greatest common factor, which is x squared. And I'm left with x squared minus 4. Okay, this was a greatest common factor factoring technique. And let's see, I'm going to take this. This is x times x. And x squared minus 4 turns out to be a difference of squares. So this is x minus 2 times x plus 2. And this I use, for that second part, I use the difference of squares. Go back again to your high school algebra. So what do I know? Well, in this case, x equals 0. In this case, x equals 0. I should put the word or in there. Or x equals 2. Or x equals -2. Let's remind ourselves of the zero product property. If a times b times c times d equals 0, then a is 0, or b is 0, or c is 0, or d is 0. So there I have them. So what are my zeros? And again, I'll put them into a bracket solution set, and I'll go from least to greatest. -2. This 0 occurs twice, so I'll just write it one time, and then +2. This is my, my set of zeros. Let's look at the graph and see them on there. Okay. So go back to my y equals and clear out what I had. This is x to the 4th minus 4x squared. I'll graph that. And you can see 1, 2, there we go. There's a 0 there on the left. There's a 0. Again, an x-intercept in the middle. And there's one on the right. You can use your second calculate button to check to see what those zeros are. So go to second 0 and we can bound it. Let's go to the one on the left here. So we're going to bound it. It's between here and here. And have the calculator check it. And there's my 0 of -2. X is -2, Y is 0. I can do the same thing for this one and this one. Or, because these are integers and my calculator is set up in integers, I can go to the table and you'll see -2 is a 0, 0 is a 0, and +2 is a 0 right there. Now, I want you to notice something. Okay, so note, if the multiple 0 of 0 is counted twice because it occurs 2 times, right? This 0 occurs twice. We wrote it once, but it takes place 2 times. Then our 4th degree polynomial has 4 zeros. 1, 2, 3, 4. Okay, if we count a multiple, if we count the multiples separately, we have 4 zeros. So notice our degree matches up with our number of zeros. We want to note that. Okay, let's go down to the third example. This is also a 3rd degree polynomial. This polynomial is x cubed plus 2x. How do we solve it? We set it equal to 0. How do we solve it? It's the same thing as saying, how do we find the zeros? Okay, well, greatest common factor is an x, and I'm left with x squared plus 2. Well, I'll write that as multiplication problem. It's factored. I can't factor this quadratic, so I'm done. Well, this is x equals 0. Again, our 0 product property. If a times b equals 0, then a equals 0 or b equals 0. So, or x squared plus 2 equals 0. Well, this is a quadratic. We can solve this when using the square root rule. X squared equals -2. X equals positive or negative the square root of -2, which is imaginary, so x equals positive or negative. Just a second. I root 2, I believe. Yes, I root 2. And take the -1 out, and I'm left with positive or negative I root 2. Okay, so what is my solution set? Well, I've got negative I root 2. I've got 0, and I've got positive I root 2. There's my solution set right there. So again, note, okay, I have a 3rd degree polynomial. And I have 3 zeros. Now, of course, this 0 is a real number. These 2 zeros are imaginary or non-real numbers, but I have 3 zeros overall. One of them is an x-intercept. 2 of them are not x-intercepts. Okay, so let's pull that together. That's how you find the zeros using factoring. And let's add to our list of what that leading term tells us. Okay, we learned in a previous video, the leading term tells us the end behavior. Using the degree and the sign of the coefficient, we know the polynomial's end behavior from the leading term. We're going to add something to that. Now we know it tells us 2 things. It also tells us the number of solutions, the number of zeros or roots. If multiple zeros are counted separately, the degree tells us how many we have. Okay, it doesn't tell us what type they are, but a third-degree polynomial tells us we have 3 zeros. In this case, 2 were non-real or imaginary, and 1 was real. I go up to example 2. Okay, this is a 4th-degree polynomial. It tells us I have 4 zeros. In this case, one of those zeros was a multiple. It occurred twice. The other 2 zeros each occurred once. And all 4 of these zeros, or 3, if you count this one, if you speak to this one one time, in this case, are also x-intercepts. They're also real numbers. So there you have it, how to find the zeros by factoring.